Test hypotheses about a population proportion for small sample sizes. Our objective? Test hypotheses about a population proportion using the binomial probability distribution. So when our sample size is too small, we're still able to test hypotheses about a population proportion. We're just going to use the binomial probability distribution. So what do we know? We know that for the sampling distribution of p hat to be approximately normal, we require n times p times 1 minus p to be greater than or equal to 10. And we know that unusual is equal to the probability of observing an event being less than 0.05 or 5%. So question, what do we do if we have a small sample size? What do we do if n times p times 1 minus p is less than 10? The answer? We can use the binomial. And in StatCrunch, we'll go to Stat, Calculator's Binomial. To calculate the p-value for us. Note, we still need to consider the equals. So always use the less than or equal to or the greater than or equal to symbols. You will get a different answer if you only use less than or greater than. So always use the less than or equal to or greater than or equal to symbols. Okay, because I want to have some space, I've got another piece of paper here for us, another sheet of paper for a bit more space. And let's take a look. In 2006, 10.5% of all live births in the U.S. were to mothers under the age of 20. A sociologist claims that births to mothers under the age of 20 is decreasing. Okay, she conducts a simple random sample of 34 births and finds that 3 of them were to mothers under the age of 20, tests her claim at the alpha equals 0.01 level of significance. Okay, first off is normal. Okay, so NP times 1 minus P. The sample size is 34. We're told that here. Our P is right here, which is 0.105 times 1 minus 0.105, and that is equal to approximately 3.20. Well, that is less than 10. Problem. Okay, can't go normal. Okay, this tells us use binomial. Okay, use the binomial. Okay, well, let's see here. Let's first off, let's talk about our null hypothesis. P is equal to 0.105. Finds that under the age is decreasing. So the alternative hypothesis is P is less than 0.105. Okay, 3, our significance level is 0.01 alpha, told right here to us. 4, let's go to StatCrunch and see if we get what we get for a p-value in the binomial distribution. So we'll go to StatCrunch. Whoops, I think I'm good. All right, that's pretty good. Let's go to Stat. Calculator's binomial this time because our sample size is too small. Come into here. Okay, I got the bottom highlighted so we can see it. Our sample size was 34. Our P was 0.105. And we want to know less than or equal to. Remember, always use the equal to, less than or equal to. Okay, and we're going to put in 3. And we're going to press compute. And we've got 0.515 to 3 decimal places, 0.515. All right, so let's come back to here and note that our P, okay, so we had N equals 34, P equals 0.105, and we had probability of X being less than or equal to 3, and we came up with 0.515, okay? So there we have it. Is this unusual, right? Is this unusual? Okay, well, unusual is, okay, is it less than 0.05? And the answer is no. 0.515 is not less than 0.05. So it is not unusual. Okay? So we do not reject the null hypothesis at the, let's see here, 0.1 level of significance. We do not reject the null hypothesis. There is not enough evidence or significant evidence to conclude that births to mothers under the age of 20 have decreased below the 2006 level of 10.5%. Okay, so a recap here. We did a test of our sample size. We came out that was too small, so we're going to use the binomial. We can still state our hypotheses, our null hypothesis and our alternative hypothesis. As a reminder, the conclusion is always written using the alternative hypothesis. We wrote down our level of significance. In the binomial, we had to note that N is 34, P is 0.105. We wanted to know when X less than or equal to 3, okay? And we came up with a proportion value of 0.515, which is significant, much higher than 0.05. So this is not unusual, okay? It's not unusual, therefore we do not reject the null hypothesis, okay? We do not reject the null hypothesis. We write our conclusion from the alternative hypothesis perspective. There is not enough evidence to conclude that births to mothers under the age of 20 have decreased below the 2006 level of 10.5%.